This is Algebra 2 with Trig, Unit 5B.1. We're going to talk about inverses and square roots, cube root functions. So we've talked about inverse functions before. If you remember, we're going to have table values where the x and the y are switched as ordered pairs. The graphs are a reflection over the line y equals x. That's why we're switching our x and the y, because we're reflecting it over the line y equals x. The domain and the range, remember the domain are the x values and the range are the y values. If we end up switching our points by reflecting it over y equals x, the domain and the range will be switched as well. Those are some topics that we talked about inverses in the past. For finding the inverses, we're going to replace f of x with y. We're going to switch the x and the y. We're going to solve for y. We did this on our past worksheet, previous worksheet. So here we are. We have this function. We'll go to 2, negative 2, 3, 0, 4, 2, 5, 4. Now we're going to create a table for the inverse. So we write that as f inverse of x. So we're going to switch these. We're going to put our x value at negative 2 and our y value at 2. 0, 3, 2, 4, 4, 5. So we're switching those. So when we plot this one out, negative 2, 2, 0, 3, 2, 4, and 4, 5. We have these new points. Notice that they are reflected over the line y equals x. Y equals x is our line that goes right through the middle of our graph with a slope of 1. So that's our line y equals x. And if you go diagonally, you'll see that we have a half a diagonal till we get to our other point. Here's one diagonal and then one spot. So we've talked about how this is a reflection over the line y equals x to find those new points. To write our equation, we notice that these points are straight. So this is going to be a linear equation. It looks like the slope is rise over run. We're going up 1. This is actually our inverse, so let's come back here. If we're going to talk about our original, we're going up 2 and over 1, up 2 and over 1. So our slope is considered 2. Our y-intercept, if we would continue this pattern over, we would be here at negative 6. So our b value is negative 6. So our equation is going to be 2x minus 6. And that is, for the equation, our original set of data points. That is y equals 2x minus 6. Now, to find it algebraically, we're going to switch our x and the y. We put the x first, 2 times y minus 6. Now you go ahead and think about how we can figure out the inverse of that function. We're going to solve for y, so we're going to add the 6 over to the other side. So x plus 6 equals 2y. So then we're going to divide each one of these by 2, which gives us 1/2 x, or x over 2, plus 3 equals y. That's our equation for our second graph. We're up here at 3. We're doing a slope of rise over run, which is 2. And we'll come in here, trying to be as accurate as I can. Down 1 over 2. We're going up 1 over 2. There's our inverse function. So this was y equals 1/2 x plus 3. So this could be considered f of x equals 2x minus 6, and this could be considered f inverse of x equals 1/2 x plus 3. Now we're going to look at a parabola. Here we're going to look at a parabola. Remember, a parabola is a U shape that would have all real numbers going in both directions. We're only going to look at x values that are greater than or equal to 0. So we're only going to look at this portion of our graph. And because it's -4, it'll actually be down here. But that's the portion that we're going to end up looking at. So if we make a table, we're only going to pick x values that are greater than or equal to 0. So we can do 0. We'll be squaring, remember, and we'll have to have answers that are less than 10. So 1, 2, 3, and 4 pretty much maximizes what we could hit for our graphs. So when we plug in 0, we'll have -4. 0 squared minus 4 is 0. Minus the 4 gives us -4. 1 squared is 1. Minus 4 gives us -3. 4 minus 4 is 0. 9 minus 4 is 5. 16 minus 4 is 12. So we can plot those points. So 0, -4, 1, -3, 2, 0, 3, 5, and 12 is going to be off our grid just a tad. This is up at 6, 7, 8, 9, 10, 11, 12 would be just about there. So that's our equation. Let me write it over here. Y equals x squared minus 4, and that has the domain restriction of x is greater than or equal to 0. Because we're not looking at the rest of the parabola. Because when we're going to do the inverse, we want to be sure that it's still a function. So there's two ways for us to plot out the new graph. One way is to use y in place of our g of x, x squared minus 4. We're going to switch our x and the y. We'll add 4. So this is x plus 4 equals y squared. And then, as we've learned, we're going to take the square root of y squared, and remember, when we take the square root of y squared, theoretically we'll have a plus or a minus. But because we're only dealing with x values that are positive, we're not going to have any y values that are negative. So we're going to have y equals the square root of x plus 4, because we'll only be dealing with our original domain. We talked about here that the domain and the range get switched. So as we begin to come to our inverse, what used to be the domain was greater than 0. Now our range is greater than 0. So we can talk about picking values in here by what fits with our equation, or we can just take the original table and flip it upside down. Negative 4 is 0, negative 3, 1, 0, 2, 5, 3, 12, 4, if we're lucky enough to get that to fit. And we can plot those points. Negative 4, 0, negative 3, 1, 0, 2, 5, 3, and 12, 4. So notice what this actually is. This here is our y equals the square root of x plus 4. So this is a square root graph. Here the square root of 0 is 0. The square root of 1 is 1, so we go up 1. The square root of 4 is 2, so we've gone up 2. The square root of 9 is 3. The square root of 16 is 4. It's just been translated over 4 units to the left. That's how you graph square root graph. Our domain of our original graph, what x values were we using? Just greater than or equal to 0. Our range were all the y values that were greater than or equal to negative 4. When we look at our domain of our inverse, what x values is it covering? It's covering x values that are greater than or equal to negative 4. Look at that, they switched. What used to be the range is now the domain. It's domain, so it's still x, but the numbers, it's no longer 0. These have been switched. And the range is going from the 0 point and greater. So our y values are greater than or equal to 0. So again, the domain became the range. The range became the domain. You still use the same x's and y's for domain and range, but the numbers follow each other as you look at the inverse. So that talks to us about how we can graph an inverse. This is an example of a parabola that we're looking at just part of the parabola. Otherwise, if we had the plus or minus, we would have had negative 1 and negative 2 and negative 3 and negative 4. We would have curved down to have our parabola on the side. We didn't want that. We were limited by our domain, so we were only on one side. Now we're going to look at x cubed. What is x cubed going to look like? Well, let's talk about finding our inverse. We'll start out with y equals 8x cubed. So we'll switch our x and the y. We'll divide by 8. So that's going to give us let's keep it exactly that, y cubed. And now we need to take the cubed root of both sides. And we have learned that when you're taking the cube root of a fraction, you can take the cube root of the top and you can take the cube root of the bottom. 8 is a perfect cube. So this is really half, because the cube root of 8 is 2. 2's in the denominator. It's half of x of the square root. Let's see. Let's put that on top. I'm going to change that up. That is dividing by 2 whatever the cube root of x was. So we can call that actually our inverse of h. If this is our h, our inverse of h is the cubed root or we might as well half cube root of x. So when you think about an a value, this is actually our a value. Okay, let's come on in and think about graphing these. One way to graph them is to consider your table. If our original h function was y equals 8x cubed, we can pick positive numbers and negative numbers. So we'll put 0 in the middle. We'll just make life easy for ourselves and do -1 and -2, 1 and 2. So when we do 0 in here, 0 cubed is 0 times 8 is still 0. 1 times 1 times 1 times 8. 2 times 2 times 2 is 8, so we're all the way up at 64. And in this case, -1 times -1 times -1 is -1 times 8 is -8. And this gives us -64. So this x cubed graph, this isn't quite the parent function, this is stretched by a factor of 8 over 1 and up 8 over 2 and up 64. So it's coming down here, almost looking like a parabola. And then on the way down the other way, -1, 8, -2, 64, it curves back through and comes this way. So now we're going to do our inverse. Well, we could put in our line y equals x. I want to be sure I hit my points correctly. So that's my line, y equals x. This is my equation, y equals 8x cubed. Now if you want to do the inverse, we can go diagonally, because this is a slope of 1, this is a slope of -1, which are perpendicular to each other. 1 diagonal, 2 diagonals, 3 diagonals, and a half. So a half, 1, 2, 3. So that is 8, 1. Zero, 0 is still at the exact same location. One diagonal, 2 diagonals, 3 diagonals, and a half. So half, 1, 2, 3. So that's -8, -1. So notice what happened. Even when we reflected it over y equals x, we are switching the x and the y from our two tables. So just to continue that, these would be switched as well. So our graph, try to draw that with our different color here. It's not a straight line. It's got that little bit of a curve coming right through here. It's not very pronounced because it's been so stretched. So this is y equals the cubed root of x divided by 2. What usually would have been the cube root of 8 is 2. We're now doing half of that, which takes us to 1. Cube root of negative 8 would be negative 2, but we're doing half of that because that's our equation we're working with. The domain of the original graph, you could plug in any value of x, so it's all real numbers, and it's clearly going up forever, so it's all real numbers. Our domain of the inverse, it's clearly going to the side forever, and it's slowly but surely going lower or going higher. So again, the domain of the original function is the range of the inverse. So those are your two graphs. Let's take a look at our little summary. We're talking about a square root. The most basic one is the square root of x. You could also talk about it as a power of a half. Your domain, what numbers you can plug in for x inside of a square root, are only the numbers 0 greater than or equal to 0, regardless of which method we're using. The inverse of a square root, when we did our inverse, that would be y equals x squared. But we would have to restrict our domain because we're only dealing with x values that are greater than 0. Therefore, we can only have a range here that is going to be greater than 0. So our domain restriction here is also x is greater than or equal to 0. That is shown, that's illustration, is shown right here. The parent function would really start at 0, 0, but it curves up. And when we do the inverse, it's curving over. And it's going right through the line y equals x. With the cube root, of course, that's the cubed root of x, which is x to the 1/3 power is another way you can write it. That would have a domain of all real numbers, and the inverse of that is going to be y equals x cubed, and there is no restriction. And that illustration is right here, where x cubed is climbing up, where the cubed root of x looks much more like it's lying down. That's our notes for today.